So good evening to one and all. Is the video and audio clear for everyone? Say, is it clear to all? Thank you. So do you have any questions with regard to the transportation problem? What we did earlier on two methods. One is northwest corner method and another one is least cost cell method. So did anyone have any doubt? Say the approach of the problem in solving that. The two methods so far we have discussed earlier. Yes or no? What about the others? Any questions for anyone in the two methods? Northwest corner method and least cost method or the matrix minima method? If everyone is clear over these two methods, then I start with the third. Shall I? Thank you. So the objective of today's session would be, so we are going to discuss the transportation problem to find a feasible solution with respect to VAM, Vogel's approximation method. Then after finding the feasible solution, how to optimize it to find the optimized solution or the optimal solution. So that we are going to discuss for today, right? So for the upcoming sessions, we are going to discuss about the degeneracy of transportation problem and what about maximization case in transportation problem. There the concept of transportation problem will complete. Then I will just take one session which is on assignment problem. One session is more than enough to solve the problem. So their total linear programming part completes. So that is my view for the upcoming sessions and today's session. Okay. Okay. So let us start the session. So I am going to take the same problem which we have done earlier. So we have the sources as well as destinations. 3174, 2659, 8332. And the demand is given by 250, 350, 400, 200, and supply is given by 300, 150, and 500. Okay, so these are supplies are nothing but the availability, and these are demand requirement. So we have done the same problem with regard to northwest corner method as well as least cost method. I hope those solutions are available to you. We have done the problem already. Am I correct? Okay. Now let us go with VAM method. We can also call it as the method of penalties, the approach is similar to least cost cell method. At the beginning, what we do, for every row and every column, we calculate the penalties. Here penalty is nothing but for each row, we take the difference between smallest and second smallest element. So if you take the first row, the smallest one is 1 and the second smallest is 3. So what would be the penalty here? The difference between these two, 2. So we calculate the penalties here, the row penalties, here the penalty is 2. So if you go with the second one, the penalty is 3. If you go with third row, the penalty is 1. We do the same thing for column 2. Here, if we calculate the column penalties, we can call it as row penalties, we can call it as column penalties. Here the value is 1, here the value is 2, here it is 2, here it is 2. So occasionally a tie situation will happen so that some penalties are equal, right? So after calculating all these penalties, we go with the maximum penalty. Among which, what is the maximum penalty? On the whole, rows and columns. Are you getting the concept? Any questions for anybody? If you have doubt, I will start at the beginning also, right from the beginning. Thank you. So, highest penalty is 3. It is happened for the row. So, in this row, we pick up the minimum value. The minimum value is nothing but 2. So, we allocate for 2. So, we are taking the least cost method approach. To select the least cost, we are calculating the penalties. For each row, we calculate the penalty, nothing but the difference between smallest and second smallest. Similarly, for each column, we are calculating the penalties, the smallest and second smallest difference. Among all these penalties, we are taking the maximum penalty. Occasionally, maximum penalty will be equal for a row and column. We can take arbitrarily, no problem at all, because in the next iteration, that is going to be eliminated. So here, 3 is the maximum penalty, which corresponds to the second row. In the second row, 2 is the smallest element, we go for this. Now the procedure is common, take the supply and demand. So here we allocate 150 to 2 and it gets striked off, it will become 100. And since the value becomes 0, we eliminate this row. Is it clear to all? Right. So here penalty means the difference between smallest and second smallest. Right. See, if you go for a least cost method, what we are going to do, after having supply and demand, for this element, you take the minimum of these two and the minimum will be allocated here, isn't it? So that minimum value will be allocated to the number and the difference is subtracted here because the rest is available. In other words, you can supply 150 value so that 100 still remains there. You are going to distribute in the further sessions, isn't it? Yes or no? Right. Does it clear for everyone? Any questions? Fine. Now, since this row gets 0, I am going to erase this. So I am going to erase this. Actually, we need to strike off. For a better clear way, I am erasing this. Now, I am calculating the penalties again. Again, I am calculating the row penalty as well as column penalty. So here the penalty is 5. Here the value is 2. Here the value is 4. Here it is 2. If you calculate the penalty here it is 2 again, and here it is 1. Is that fine to all? Right. Now which one we need to choose now? The maximum among the penalties. First column. Right. So in the first column, again we follow the least cost approach. So for 3 and 8, we go with 3. So if you take the demand as well as supply constraints, 100 will be allocated to 3 here. So this 100 will be subtracted from here. So it becomes 200. So it becomes 0. This column gets striked off. Is it acceptable to all? Any queries to anyone? Right. Now I am going to erase this column then. This is the remaining part. Again, we are going to calculate the penalties. Fine. Now, you calculate the penalties and tell me where you have to move now. Is our approach correct in the total? Did we miss anything there? If you have entered any value wrong, we are going the whole process as wrong. Right. So again, we are calculating the row penalties as well as the column penalties. So here the value is 2, the value is 4, the value is 2. Again, you have 3 here and you have 1 here. So among all these things, the maximum penalty happens here. So we are selecting this column now. So among which the smallest value is nothing but 3, and we are selecting this one. Clear to all? Any questions? Right. Now again, taking view of supply as well as demand, this 400 will be allocated to 3. And it becomes 0 and it becomes 100, and this column gets struck off. Now you have the rest of the table. Now I am erasing this part. This is the remaining one. So again, we are calculating the row penalty as well as column penalty. So if you go for the next one, the row penalty here. So here the penalty is 3, here the penalty is 1. If you calculate column penalties here, the value is 2 here, the value is 2 here. So you are going to go for the row number 1. So here we go for 1 here. So 1 into, if you take care of the supply and demand, 200 is the smallest value, we allocate 200 to 1. This gets struck off and it becomes 150. So you are going to eliminate this row, and this is the balanced one. Can I move next? Is the approach clear for everyone? Any questions for anybody so far? If you have doubts, you can ask. Right. So in this way, can you calculate the value for the remaining two? So have you noted this thing? The tabular data? Right. Now the value remained is 3, 2. Here you have the value 100. Here the value is 200. Here the value is 150. So if you calculate the penalties as well, here the value is 3. Here the value is 2. Here the difference is 1. So 3 we are going to take. For 3, if we calculate these two, we are taking the difference between the values. And we should understand one thing, that if the final value is a mismatch, means we have done a wrong thing in the beginning. Have you taken all the values correct in the beginning? Are you with me? Right. So if it is a balanced transportation problem, at the end, the final value must be matched one. That's why I'm asking. I think it is a balanced one, not unbalanced one. Let us go with the beginning again, without any disturbance. Three, 1, 7, 4, 2, 6, 5, 9, 8, 3, 3, 2. The values 300, 400, 500, 250, 350, 400, 200. Now can you check, is it balanced or not? This is the problem you have taken actually, right? Please check on that. Right side whole supply value is 1200. The demand value is nothing but 1200. Right. Have you taken the same values earlier or not? Right. Then let us do it again. So let us go with the row penalties straight now. So before we had different values of supply and demand. I think here we have misplaced it. We have taken a different value here, right? I have taken a different value here earlier. Right. So in such case of problems, we are going to introduce a dummy row or dummy column, and we make it balanced and we solve the problem, isn't it? Right. Since it is balanced, again we calculate the thing. The penalties remain same. So if you want to calculate the penalties once again, I will go with the penalties once again. Shall I? Or not required? I will just take the allocation part. Right. So earlier we have gone with row 2. The smallest value is 2. If you compare with these two things, so 2 into 250 we are going to take. It gets struck off. It will become 150. This value gets cancelled. Now in the second step, after calculating the penalties, which one we have selected? Now the whole thing gets changed, isn't it? So let us calculate the thing again. Because as and when you have changed the row apart from column, the whole thing gets changed. So the value is 3 here, the value is 1, 1. Here the difference is 2, the difference is 2, and the difference is 2. So again, you have to go with first row and the smallest one is 1. Accepted? Now, for 1, we are going to allocate the smallest between these two. The value is 300. It becomes 0, it becomes 50. So, the row gets cancelled. This is the remaining table. Again, if we calculate the penalties, for the row, the penalty is 1. Here, the penalty is 1. For this column, the penalty is 3. Here, the difference is 2. Here, the difference is 7. Accepted. Now, since the highest penalty is appeared here, we are going to select this column. We go with 2 down. So if we compare the demand and supply, 200 will be allocated to 2. It gets striked off, it will become 300. The column gets cancelled. So this is the remaining part. Are you following it? Any questions? Any doubts to anyone so far? Right? Can I move further? Right. So I am going to erase these things for clear understanding. This is the thing left with me. So if I calculate the penalties here, for the row, the penalty is 1. For this row, it is 0. For this, the penalty is 3. For this, the penalty is 2. Obviously, we should go with this column. The smallest is 3. So again, if you compare these two things, 50 will be allocated to 3. And it will become 250. So this column gets striked off. So 5 and 3 will remain like this. For 5, the value is 150. Here you have 250. Here you have 400. Again, the highest penalty appeared for 5 here. So 5 into 150 will come. This gets striked off. It will become 250. So 3 into 250 is the final allocation. And we can sum up all the values. So please check that. So the final answer will be 2850. So if you compare the solution with the two methods, the northwest corner method as well as least cost method, which one is more advantageous? The method which we have taken now, VAM. Because if we have checked that, what is the value for northwest corner method? I think it is around 4,400. Say for northwest corner method, the value. Could you check on the same problem for it? What is the value for northwest corner method? So if you apply the least cost method, I think it will be around 2,900 or 2,000 something, right? So among all these methods, VAM is the most advantageous method, which is close to the optimal. In one way, you can say that, right? So any doubts with regard to the procedure so far considered with regard to VAM? Say. Yes or no? Right. So have we noted the solution? 2,850 using this method. Right. Now, if you come for the representation part on paper, we are going to write like this. So this is the tabular form which is given to us, containing the cells having the cost values. Here we have the supply. Here you have the demand. So for the presentation of paper, you give some space to supply, because supply values get simplified for each iteration. Then here you put the heading row penalties. So you can indicate that row penalty 1, which stands for the first iteration, or simply 1, 2, 3, 4, 5 and so on. So first iteration, second iteration, third, fourth, fifth and so on. We do the same thing for column penalties too. After giving a gap here, we mention the column penalties. So iteration 1, iteration 2, iteration 3, 4 and 5. So that the penalty which we are choosing, we put with a star mark. And after choosing a penalty, we are taking the least cost in the corresponding row or column, isn't it? So you highlight that with a box, whatever it is, and you are going to mention in the next page or the bottom of the page transportation cost. So for the presentation of paper, you will mention the iteration number, say iteration number 1, cell value, right, amount, total. In this way you can write the solution. Apart from cell value, you can say the cost value. This is the general pro forma to represent the solution on paper. So the whole problem will be represented on single paper. Now what happens if you carry a pencil with you? The row which gets cancelled, you simply cancel with the pencil without any hesitation. Okay? Because you are doing the problem for the rest of the table, excluding that row or column. So if you are not comfortable with this type of representation, so for every iteration you are going to write the whole table, table by table, table by table, etc. Clear? So any doubts with regard to the presentation on paper? To anyone? So far considered? So if you clear with this procedure, VAM, I am going to take one unbalanced transportation problem with regard to VAM method. Shall I continue by taking a unbalanced transportation problem, right? Then I go with the optimization technique. Just hold for a second. I am going to take the problem which is unbalanced. So 10, 2, 16, 14, 10, 6, 18, 12, 13, 16, 8, 4, 14, 12, 10, 14, 22, 20, 8, 18. This was the table. Corresponding supply and demand are given by 300, 500, 825, 375, 350, 400, 250, 150 and 400. So after checking this, now tell me what we have to introduce, a row or column. Since the problem is unbalanced transportation problem, you tell me on what side we are going to go for, dummy row or dummy column, to make the problem as balanced. Right? Let us wait for the response of the others too. Right? So we are going to introduce a dummy column by putting all zeros there. So I am going to take the table like this. So 0, 0, 0, 0. What are the value I have to take here to make it balanced? 450, right? So what is the sum of total supplies and demands? As you have calculated, 2000, right? Now I avoid calculating the penalties since you are going to do that, row penalty as well as column penalty, and you just tell me which row or column I have to choose now. Under this VAN method for the first iteration. Second row. So while calculating the penalties, you are going to take the consideration of zeros also as well, right? Now, if we calculate the penalty, here the smallest value is 0, second smallest is 2, so the row penalty is 2 here. Here the smallest value is 6, here the smallest value, the difference is 4, here you have 8. If you go with the columns, the difference between smallest and second smallest is 2 here. Here you have 2, here the value is 2, here the value is 8 and 12, the value is 4, here the value is 10, 10, 0, here the value is 0. Right? Accepted to all? The row penalties as well as column penalties. Fine. So among which the highest penalty is nothing but 8. So we are going to take the fourth row. The smallest element here is nothing but 0. Now we are going to allocate 0. Right? So if we compare these two, 375 will come for this 0. And this 450 will become 75. Accepted? Right. Now, since 375 is allocated here, this entire row gets cancelled. Now you have only this one, these 3 rows on the corresponding columns. Again, we are going to calculate the row penalties as well as column penalties. So again, you have the value 2 here, 6, 4. This won't happen here. Again, if you calculate for the penalties, 2, 2, 2. So here the difference is 1. Here the difference is 6. Here the difference is 0. Accepted to all? Any questions in calculating the penalties for the second iteration? You please check on it and give me your suggestion. So while calculating the penalties, so here, yeah, it will be 0, right? Accepted now? right? Now, which row we are going to take now? Row number 2, where the penalty value is 6. So if you go and choose this one, the smallest value here is nothing but 0 again. So you are again allocating for 0. If you compare the supply as well as demand, this 75 will be allocated here. So it will become 425 and this column gets cancelled. Now this is the rest of the matrix. Again, you are going to calculate the corresponding rows as well as column penalties. Now one observation here is the dummy row or dummy column, what we are introducing here will get cancelled either in the first iteration itself or in the second iteration. It cannot be prolonged for third and fourth iterations in general. So after calculating second iterations, it will be gets cancelled. Second row we have to cancel means, see, the supply here is 500, here the demand is 75, isn't it? So this 75 will be allocated here, so it becomes 0, so that column gets cancelled. And 500 we are subtracting 75, it will become 425. So for each cell you have a supply and demand. Say it is 150, it is 100. Among the two values you are taking the minimum, so this minimum will be allocated here and the same is subtracted from these two. So it will become 50, it will become 0, so the column gets cancelled like that. I think the approach is clear for everyone now, right? So can you calculate the other penalties, row and column as well? So if you're interested, I am going to erase these two things so that the table looks nice. Shall I do like that? Right. I am erasing the penalties as well. This is the remaining matrix left with me. So again, I am calculating the row penalties as well as column penalties. Here the difference between smallest and second smallest is 8. Here the value 6 and 12, the value is 6. Here the difference is 4. So if you calculate the column penalties, the penalty is 2 here, the penalty is 2. Here also you have 2, here you have 1, here you have 0. Accepted? Right? So now you are going to choose the first row in which the smallest value is 2. For this you are allocating. So if we compare these two, the 300 will be allocated to 2. So 2 into 300 we are taking. It gets cancelled. It will become 100. Please check that. Accepted. Fine. So the row gets cancelled now. This is the remaining thing with me. So if we calculate the next penalties, row penalties, again here you have the value 6. The value 4 won't change. Coming for column penalties, 2. Here the penalty will be 14. Here the penalty is 2. The penalty is 1. The penalty is 6. Accepted? I think you are solving the problem on your own. I hope so. Say. So among all these penalties, the highest penalty is nothing but 14, which happens for this column. In this, the smallest value is 4. So for 4, you are allocating the things. So for 4, if we compare the supply and demand constraints, the smallest is 100. So 4 into 100. So this 100 comes here, and we are subtracting the same value here. It will become 725, and the column gets cancelled. Please check on that. Accepted to all. So if you are clear with this table, I am going to erase the cancelled ones so that you will have the clear notation and view on what table we are going to perform the iterations, because you have already noted that. So can I erase these rows and columns, the cancelled ones on board? Okay. So this was erased. This was erased. I am going to erase the rows penalties and column penalties as well. This is 425. This is 725 on simplification. Again, I am calculating the penalties as well. So for row penalties, here the difference is 6. Here the difference is 2. Here you have the value is 2 here, 2, 1 and 6. Now you can observe a tie situation here. You have the row and column penalties are equal. So in this type of situation, you can choose either of the two. This or this you are going to follow. Now tell me which one you are going to choose, the row or column. We can choose arbitrarily while calculating the penalty and selection of the cell. Please tell me which I am going to choose, row or column penalty. Say row, right? So if you go with the row, the smallest value is 6. I am going with 6 now. So if you calculate the demand and supply, it is 350. 350 will be allocated here. So it gets cancelled and it will become 75. Again, if you calculate the row penalty as well as column penalty, here the value is 1. Here the value is 2. So here the value is 2, the value is 1, the value is 6. So again 6 we are going to choose. The smallest value is 10 here. We are allocating 10. The smallest is 400. So 10 into 400. It will become 325. The column gets cancelled. This is the remaining matrix. Please check on that. So can you move further and calculate the remaining penalties and allocations on your own? Can you go on your own for the calculation of the solution? Please tell. So let me know, do you have any doubts with regard to the approach so far considered with regard to this method to anyone, right from the beginning onwards? Yes, answer is 12,250. I agree with you. The final answer is 12,250. So let us wait for the others too, whether they have done it or not. If you have a doubt, I will do the rest of the problem also. Please tell. So once we have done with the problem, if you check your paper, all rows and columns will get cancelled completely. It looks very confusion. So to avoid confusion, you can write the total solution into two parts. For the first 3 or 4 iterations in one part and the remaining in other part, so that the table looks nice. If everyone is finished with that, then I am going to go for the optimization technique there. How to find the optimal solution. So if everyone arrives with the answer 12,250 for this problem, then you are done. You have applied the WAM method correctly and you have found the solution. So can I skip the rest of the part? Thank you. So I am going to erase this thing. May I? Fine. Now, how to find the optimal solution? So you have applied 3 methods so far. NWCM, least cost cell method, and WAM. So for a given transportation problem, you can choose one of these 3 methods and you will find one feasible solution. And what is the checking criteria that the solution obtained is feasible? Since the problem has m rows and n columns, after doing with the problem, you should verify that m plus n minus 1 allocations are there. If there are m plus n minus 1 allocations, the solution obtained by you is a basic feasible solution for the given transportation problem. If the number of allocations are less than this thing, means you have a degeneracy in the problem. That is a separate case we are going to discuss on Monday. Okay? Is it clear for all? Right. So the number of allocations must tally with m plus n minus 1. Now, after having this solution, you are going to optimize that. There are different methods available. One method is UV method, also called as MODI method, modified distribution method. So using this technique, we are going to find, or we are going to derive the optimal solution from the feasible. Okay? Is that clear for everyone? Right. Now I am going to do the same problem again. The first problem of today's class. There you have obtained the feasible solution as 2850, and using that you are going to find the optimal solution from it. And you are going to verify whether the solution is optimal or not. Okay? Fine. So after finding the initial solution or the feasible solution, we are considering the table again. Let me write a little lower. So this is the solution we have obtained there. 3, 1, 7, 4, 2, 6, 5, 9, and then 8, 3, 3, 2. The corresponding supply and demand are given there as 300, 400, 500, and here you have 250, 350, 400 and 200. And coming to the allocations part, for this you have allocated earlier 250, and for one you have allocated 50 there, and in the second row you have allocated for 6 300, and for 5 you have allocated 100, and in the third row for 3 you have allocated 300, and for 2 you have allocated 200. So could you check on the allocations please? Did I write correctly the allocations? By taking confirmation from your side, I am going to move. All of you agree with the allocations part? Right. Now, in this table, you have made some allocations to some of the cells. So, the cells where you have made allocations, they are called as basic cells. In other words, they are the basis for the solution. The remaining cells where you didn't made any allocations are called non-basic cells. Now, again, for the non-basic cells, you are calculating the penalties. You are calculating the penalties for the non-basic cells, right? How we are doing? So we will indicate the symbols for these rows. Let us write U1, U2, U3. First row, second row, third row, because we are calling it as UV method. And the columns you will write V1, V2, V3 and V4. Now, for the basic cells, using the formula, we are calculating the values of U and V. The thing is, the value in the cell, that is 3, it must be equal to the sum of these two. So 3 is equal to U1 plus V1. That means the row value plus column value is equal to the cost of the cell value. Now you can choose the value that either in the first case V1 is 0 or U1 is 0. So in general we go that U1 will be taken as 0, and to balance the equation V1 is equal to 3. Is the first step clear for everyone? right? Again, we go with the basic cell in the same row. Is there any other basic cell in the same row? Again, you have other cell. So this value must be equivalent to sum of these two. So since u1 is 0, v2 must be equal to 1. Accepted? Yes or no? Fine. So there are no more allocations in the first row. Then I am going to the second row. In second row, again I have two allocations. I can start with this or this. Since this value is known to me, so comparing these two, I can say that u2 is equal to 5. Accepted? Fine. So since this is 5, summing up these three values, this must be equal to 0. So I am done with the second row. Now I am going with the third row. Here I have two allocations. I can go with either of the two. So since this value is known to me, I am going this that u3 is equal to 3. Again, for this one, since the value is 2 here, the sum of these two things must be equal to cost value. So this must be equal to -1. This is the first step I have done. Any doubts for anybody so far? What I did? Please check on that. Say. Any questions? Yes. At the first, we can put this value is 0 and this value is 3. No doubt at all. Not only this, you can start with these three things also. This is 0, this one you take it as 1. Traditionally, we start with the first row and first column, or you can straight away start with this one. So this is 0 and this is 1 you take. That is also acceptable. There is no restriction that always we should do with the first one. In the solution, we have allocated 300 in the first row. I hope it is. I am taking the values from VAM. Could you check on that? The allocations what we have made. Right. So is everyone comfortable with the things what I have done here? Because it is a little tedious procedure to calculate the things. You should have a good observation as well as the calculation thing. Right. So by checking with the basic cell values, I have computed what is u1, u2, u3 and v1, v2, v3, v4 values. Now I have the non-basic cells remained 1, 2, 3, 4, 5, 6. For the remaining non-basic cells, I am calculating the penalties. So penalties will be indicated symbolically as Pij or delta ij, also called as improvement index. The formula is ui plus vj minus of cij, or you can take the difference of this thing. Both are acceptable. Right? What you are doing? Summing up the two values and taking the difference of the cost value. Or take the cost value, take the difference of these two. Clear to all? Right. Now, if you take this one, let me take this formula I am taking. 0 plus 0 minus 7. So this is negative. I am putting a negative sign here. So what I am doing for the penalties, I am writing the penalties in the suffix, the leftmost, this part. Again you have minus 1, minus 4, this is negative. Again if you calculate 5 plus 3, 8, 8 minus 2, 6 you have here. Again 5 plus 1, 6 minus 6, this is 0, there is no need to allocate. This is 0, there is no need to allocate. And these are basic cells, there is no need to go for basic cells. Again for non-basic cells, 4 minus 9 minus 5, so it is negative. Again this is negative. Again 3 plus 1, 4, 4 minus 3, this is positive, 1. Again this is basic cell, this is basic cell. That's what I have did. Please check. For the non-basic cells, I am applying this formula. Are you getting the concept? Any questions so far? If anyone has any doubts with regard to calculating these penalties, you please inform. I redo it again. How I have written negative, how I have written the suffix values. Any questions please? You please tell. If everyone is clear with that, then I move ahead. So if you take the second formula, it will become as positive or 0. That's the only thing. The negative values will become positive and the basic cells will get 0. And here I got 6 and 1, they will become negative here. That's the only thing. It will become minus 6, it will become minus 1. That's it. That's the only change. Different others will use different notations. So if you use this formula, the value you have, see what I am doing, Cij minus of ui plus vj. So this is 7, 7 minus of ui plus vj, 0 plus 0. The value is 7. So this will be positive. What I did there, 0 plus 0 minus of 7, that's what I have done. Clear? How the formula I have applied there. The corresponding row number and column number minus the cost value. I did like that. 0 plus 0 minus 7. 0 plus minus 1 minus 4. 5 plus 3 minus 2. Again 5 plus minus 1 minus 9. Is that clear for everyone? There is no need to write the negative values. See, by using the feasible solution, what we have obtained, by using them, we are finding the optimal solution. The condition for optimality is all the values must be less than or equal to 0 for the penalties. After calculating the penalties, if all the penalty values are less than or equal to 0 means the optimality is achieved. There is no need to do any modification in the solution which you have obtained. If there are some positive values, then you need to modify the solution. That is the checking condition for optimality. If you use this formula, then all the values must be greater than or equal to 0. If there are some negative values, so that you need to modify the solution. That is the case to check for the optimality condition. Okay. Can I move ahead if the step is clear for everyone? Right. Now see, here the real thing comes. How to modify the solution? Please understand that these values are supplies and these values are demands. You are improving the solution means without violating the constraints of supply and demand, you are doing some allocations or you are modifying the allocations. That is a basic thing. So here you got two allocations, that here I got the value 6, here I got the value 1. So that these two values I can improve. In other words, in the two cells, I can do some allocation so that the solution will be improved or I can find a better solution. So among the two positive values, I should go with the most positive, that is 6. So I am taking the cell having the positive value 6, the positive penalty value 6. So I am calling it as X. Now what happens? How I am improving? From this cell, I move to the basic cell, and return. So that I will have a closed path. So what I am going to say is, from this you can move either horizontally or vertically, not diagonally. You can move horizontally or vertically from basic cell to basic cell, and you should return to the same position so that you will get a closed path. The closed path may be of either of the type. It will come like this, a closed path, or it will come like this, or it will come like this. Any of the closed path you can have. In general, for most of the times, you will have a closed path like this or like this. Okay? Are you getting the things or not? Now, this is my starting position. I am going to improve the value here. So to this, I have two basic cells nearby. Please understand, basic cell may be here, here or here, anywhere. So we are straight away moving to this way and this way. That's what I am saying. If the basic cell is not nearby, if it is in the last position, you can go straight away along to the last position. So let me draw a small picture so that you will have an idea. So this is the thing I got. So this value I want to improve. Here I got a basic cell. Here I got a basic cell. Here I got a basic cell. See, near to this point there is no basic cell at all. They are distant. Now how I am moving? I am moving like this. You can move like this also, no doubt at all. Clear? I think the concept is elaborated for everyone. How I am moving in the rows and columns. Right. So from this to this I will move, then I will move here, then I will move here, I will come back. So I want to draw a separate picture for your understanding. So here the value is 2. There is no allocation made here. That's why I put the symbol X. Here I have made the allocation 300. Here I made the allocation 50. Here I made the allocation 250. Now the point where you are starting, we indicate the symbol plus because it is positive here. So from this point onwards, we indicate the values alternatively. Since this is plus, it must be minus. It must be plus. It must be minus. So I am taking the symbols alternatively plus minus like this in the closed path. Are you getting the thing? We don't move diagonally. We move only horizontally or vertically. Please understand the transportation problem is nothing but rows and columns, nothing but sources and destinations. You are moving from one source to another source and one source to another destination. If you move diagonally, what does it mean? If you think of, so we don't move diagonally. We move from source to destination, destination to source, like that. So we don't move diagonally. Clear? Right. So generally, after forming a closed loop, in the allocation numbers, what you got, some values are positive, some values are negative. So in the negative values, you take the smallest value. So what is the smallest value is there? See the closed path, what I have written there. What is the smallest value there? This is plus, minus, plus, minus. I have two negative values, among which 250 is the smallest. Accepted? Now, this 250 is coming to my position where I want to have the improvement. And the same value will be subtracted from the negative ones and added to the positive ones. So if I add 250 here, it will become 300. It will become 250. I am subtracting 250 from the negative valued things. So it will become 0. It will become 50. Clear? So I repeat again, I have a closed path from basic cell to basic cell. That is step 1. After finding closed path, what I am doing? I am giving symbols alternatively plus minus plus minus. The step where I have started will be treated as plus. All the remaining will be taken as plus minus alternatively. Then all the negative signed allocations, I am taking the smallest value. So I am subtracting the smallest value from the negative side ones and adding the same thing to the positive side ones, so that you have a result. So how it is coming? It will become 0. Here I have made an allocation 250. So here I am subtracting, so it will become 50. It will become 300. Does it make sense for you? How I have changed it? Please respond. If anybody has any queries, you can ask. How I did. Right. So this 6 I have taken earlier. Please understand how this 6 has come. See, what is the formula? Ui plus Vj minus of Cij. Ui is 5. This one is 3 minus 2. So the value is 6. Clear? 6 with, this is the cost value. This is the original cost, the table. 3174, 2659, 8332 are the tabular values, the cost values in the table. Those are not penalties, the cost values. I have indicated the penalties with a box in the suffix like this. I have just written only 2 penalties. This is 1 penalty, this is 1 penalty. Remaining all penalties are negative. Yes, basic cell to basic cell. Basic cell is nothing but where I have made an allocation. So this is the cell I want to improve earlier. So the nearest basic cell is this. So here to here I moved, again here, like this I have moved. and 6 with allocation 50, I have taken the values from VAM because we have done the same problem with VAM in the commencement of today's session. Clear? Are you getting confused with the procedure so far described or not? Can I move further? You were asking that how this will be a basic cell. Is it you are asking? Yes, that's what I am saying. It is not allocated earlier. I have made a closed path. After this, I made it the basic cell. What I am doing? Subtract minimum of negative signed cells, add the value to positive signed cells. This what I did. Since you are getting confused, let me draw the thing one more time for you. This is the thing earlier I have with me. This is the thing I have got earlier. This is the thing 300. This is the thing 50. This is the thing 250 earlier I have. So this is positive, negative, negative, positive. Sorry, positive, negative. Among the negative things, I am taking the smallest one. This will be transformed like this. 250, 50, 300, 0. This closed path is changed like this. Please understand. Yeah. Now I am saying this has penalty 6. It has penalty 1. We are picking the maximum penalty. Please understand that penalty means what? Where the transportation cost is more. Penalty indicates the transportation cost. More penalty means it takes more cost. Or you can have that, we are calling it as improvement index. Here you can improve more compared to this. That is the underlying idea. Okay now? Right. Is this clear for everyone? What I did so far? How the closed path is retrieved and modified and the new allocations made. Yes or no? Fine. Now, this procedure is a lengthy procedure. After allocating the things, after modifying the table, again you need to compute the whole UV values. Now you can understand one thing, that if you modify the closed path like that, the supply and demand constraints will not get violated. Please understand, sum of the supplies must be 300. So see, 300, 300. Sum of the supplies must be 400. So 250, 50, 100. Sum is 400. Sum of the demands must be 250. So 250, 250 matched. 300 plus 50, 350 matched. So that the closed path is constructed in such a way that we are moving from basic cell to basic cell without violating the constraints of supply and demand. That is the underlying idea there. Does it make sense? We are moving in such a manner only. So if you understand that for the third row, the total supply is 500. Here it is 300, here it is 200, the sum is equal to 500. Accepted? Right. Now again you are going to calculate U1, U2, U3 values. So for each basic cell, based on this, you are calculating one more time U and V values. Again, identify the penalties. Where you have a positive penalty, you are going to take the most positive penalty. So if you calculate again, the penalty will come here because we have a positive sign here earlier. Obviously, you need to improve this thing. So this thing will be X here. Again, you are moving from basic cell to basic cell. So here nothing is allocated. The basic cell is 300 here. So this is 300. This is the basic cell, value is 100 here. This is the basic cell, value is 50. So plus, minus, plus, minus. Is it fine? Again, if you take the negative symbols, the minimum of the negative symbols is 50. So 50 will be allocated to this position, separated here. So this path will be changed as 50, 0, 150, 250. So it will be modified as 50, 250, 150, 0. Now again we calculate Uy and Vj values. Always optimality is reached here, and if you multiply the corresponding values, that is the optimal solution. However, the optimal solution in this case is nothing but 2850, that is obtained by VAM, but the allocation is different. However, after finding the optimal solution, sometimes the value of VAM will coincide again, sometimes you will get a different value. Yes, same allocation. Yes. In general, yes, in general, if you go with VAM, after having the optimal solution, you will get the value somewhat reduced. In this case, the same value will come. So let me say one thing, that if you have started the solution, the feasible solution is taken by northwest corner method. The value is 4400. If you apply this method, after finding the optimal solution, you will get the value as 2850. Okay. I have taken this example because you will get very easily understood by the modifications taken place in the tabular data. How to calculate Ui, Vj, penalties, and how to construct a closed path, how to do the allocations based on the closed path, and how to do the final solution. That is my intention to say here. So I think the path is clear for everyone. How to check the optimality and how to construct the closed path. How we will write properly in exam. Exactly. To find the feasible solution, it is our choice. You can go with northwest corner method, least cost anything. Please understand one thing, that the northwest corner cell method, you are just performing 2 more iterations or 2 iterations for applying the modified method. There is the thing, the iterations will take 1 or more, that's all, but the procedure is similar, whatever the approach you go on to take place. So if you're interested in the upcoming class also, I will take one more problem on the same optimality method. Is that required for you? Say. So on Monday also, I am going to take, yes, exactly. The problem is lengthy. I always agree with you. That's why as and when one single question is given, the weightage will be 25 marks. At least 20 marks will be given for the optimality problem. Earlier in 2000, etc., 30 marks is the weightage for one single problem as and when optimality is asked. Fine. So let us wind up our session here. We will meet Monday on again with one more problem on the optimization technique so that you will have a good understanding. Then we discuss about the degeneracy case. So good night to all. This is a lengthy problem. One should understand.